So I have this fresh formula sheet that I just wrote. I'm going to go through each individual thing, try to do it in 18 minutes. So the first thing is, if there's no Vs, Is is just sum of the V divided by the sum of the R. So if you have, and again it says parallel up there, so everything here is for parallel. Okay, so if you have, draw this here, this R1, R2, R3, Is is equal to V1, R1, V2, R2, D3, R3. So this current splits into three separate paths, right? Like that. So this is the same as saying that Is is equal to I1 plus I2 plus I3, which is the same as saying as Is is equal to In is equal to I out. So everything going in here is the same as everything going out here. So this is kind of very basic. The next thing here is we have this formula for Is times Req is equal to In Rn, which is equal to Vn. Okay, so we know that Vn is equal to In Rn. Okay, we also know that all the V's are the same, right? So it's just equal to delta V A to B for the parallel circuit, right? So if we simplify this down, Is Req is the same delta V A to B. Right. So we can put this up here. Is are equivalent. And then we solve for In, where In is the individual current, Rn is the individual resistor. Delta V A to B is AB all the way across there. Okay, so solve for In. In equals Is are equivalent divided by Rn. Okay, and this is no Vs. So you got to keep that caveat because it changes a little bit once we introduce Vs. Okay, so that changes that. So Is sum of the I is the same as what we said here, where sum of the In is equal to sum of the I out. Okay, so I've explained and proven all these formulas here. So the next thing we go to is, if there is Vs, we say Vn is equal to sum of the Is times the R equivalent. Okay, so V is equal to IR. Right, so what I said is Vn is equal to sum of the Is times R equivalent, which is what we already said before. It's just written slightly differently. Okay. Okay. So we have Vn is delta V A to B. So we mark A, we mark B. So if I add a voltage source, and I call this Vx, delta V A to B is now Vx plus Vs if they have the same plus minus direction. Okay, so delta V A to B is now Vx plus Vs. Right? So all that I have to do is I can use the same formulas can use the same formula, except for I now have Vn now has multiple values. Okay, so In is equal to, Vx plus or minus Vs divided by Rn. So if Vs is 0, obviously Vs just goes to 0. Okay, so we say Is is equal to sum of the I out, going out of the point A. So Is is equal to Vx plus or minus Vs divided by Rx, plus R1, V1 R1 plus V2 R2. Right. So what this is Is equal to Vx plus or minus Vs divided by Rx plus the sum of the Vn over Rn. So everything with a source plus everything, and this is all parallel, this is only with parallel. And I put that up here, where everything over here, this is all parallel, or everything to here is parallel, and then series, this stuff is all series. Okay, so if we look here at this formula, it's the same formula that I wrote in here. Sum of the Is out is this, so Is out, Is, So what this translates into is this kind of translates into another source. So this, the voltage source can be translated into a current source with a source transformation. And that if you do the source transformation, it will prove this formula as well. Right, so you do the source transformation real quick. This turns into this. So if we have VSR in series, it translates into ISR in parallel. So this is the new piece that would be attached up here. So all of this would be attached, and this kind of like AB, AB would actually be here to here. There'd be another one in the middle. So all of this would be delta V A to B. So delta V A to B, because remember this piece is the same as this up here. So here you have AB, here you have AB. Here's the resistor in the middle, is equal to, V is equal to IR. So delta V A to B is equal to this new IS times R. So ISN times R, ISN is equal to VS divided by R. Okay, so you can see that when you do it this way, you do the source transformation. If I plug in Vs divided by R, delta VA to B is just the same as Vs in this case, if we do it that way. Okay, so what that means is there's a conflicting answer here. The way I explained it up here, delta VA to B is Vx minus Vs But if I just do the source transformation like this, then delta V A to B is just IS divided by R. Okay, where IS is VS divided by R. So there seems to be a contradiction between the source transformation and this method that I used up here. And it's slightly confusing. So that's kind of a contradiction that I ran into.